Alrighty, if we take a look at circumference and arc length. So circumference is like the perimeter of a circle, and we can find it two different ways. We can take pi and multiply by the diameter, or two radiuses equal one diameter. So we can do 2 times the radius times pi as well. So this question's asking us to find the circumference in terms of pi. So in terms of pi just means that you don't multiply out pi. So our circumference formula is pi times diameter. The diameter is 10. So I'm going to say pi times 10, which we're going to call it 10 pi. So the circumference in terms of pi is 10 pi. Find the circumference of a circle with the radius of 9 centimeters. So this time I know the radius. So I'm going to use 2 times radius times pi. And I'm going to keep it in terms of pi. 2 times 9 times pi. My circumference is 18 pi centimeters. Radius of a circle with a circumference of 26. So again, I'm going to work backwards this time. And I'm going to say, all right, the circumference is 26. And I need to divide by 2 and pi. So divide by 2 pi. So I'm going to get 13 over pi equals my radius. 13 divided by pi is my radius. So again, if you wanted to use your calculator, 13 divided by 3.14, and you could get the answer. Arc length is not all the way around your circle. So again, the circumference is all the way around, and arc length is just a section or an arc of the circle. And so you can kind of see here, what we do is we set up some sort of like proportion. So I always like to look at things in geometry as like a part to whole ratio. So we're going to look at part of the circle, which is again our arc length. So part of it over the whole thing, which is the circumference, equals, well, whatever degree measure. So again, whatever in central angle, let's call it our central angle, all over, how many degrees does a circle have? 360. So again, it's a part to whole ratio because these are parts of the circle, whereas our denominator is the whole thing. Now, again, excuse me, we have two different pi times diameter or 2 radius times pi. We have two formulas we can use for that. So we're going to use this to set up our proportion basically every single time. So arc length, I'm trying to find arc length, okay? Over the circumference. The circumference is 2 times the radius times pi equals my central angle is 60 all over 360. So if I start to simplify, again, arc length is really, if you want to think about that, arc length is really like my variable, x. What am I trying to solve? So I'm going to simplify 2 times 8 to get 16. And then I'm going to cross multiply. So I'm going to take 16 pi times 60 and x times 360 and get 360x equals 60 times 16 is 960. So I have 960 pi. And this is real easy to solve. All we have to do is divide by 360. So 960 pi divided by 360 gives us the length would be about 8.378. So the length of AB is about 8.378, we'll call it. Another example, I'm going to set up a proportion, basically the same type of proportion, where we're going to go find our arc length. Again, this is like our variable over the whole thing. The whole thing is the circumference, which is 2 times my radius times pi equals my central angle over 360 degrees. So I'm going to really, when I cross multiply, I'm going to get 360x equals 2 times 11 is 22. So 22 times 60 is 1,320 pi. So again, I'm going to take this answer and divide by 360. And I get an arc length. So the measure of EF is about 11.519. Still use the radius. So again, if I'm looking for my arc length, I'm just going to call it x over my circumference, 2 times 11 times pi equals, my central angle is 120 this time, but the circle still has, again, a part to whole of 360. So 120 times 22 pi, 2640 pi equals 360x. Divide by 360. And we're going to get an arc length of 23.038. All right, let's take a look. This is slightly different. So again, I'm going to set it up the same. I'm still going to use this setup right here, but I'm going to find different. I need to find something different. So this time, again, my arc length I know is 4.19. The circumference is what I'm trying to find. So that's going to be my x. This is what I'm trying to figure out. Again, part to whole equals 40 over 360. So now when I cross multiply, so setting up your proportion is by far the most important, because once you get the hang of setting it up, it's just cross multiplying and dividing. Let's see here, 1508.4, and then when we divide this by 40, we're going to get the circumference equals about 37.71. So what's different than the first three examples is the first three examples we were finding the part, we were finding the arc length. Now we're finding the whole, which is circumference. Find the measure of RS, so that's right here. So we're trying to find, in this case, we're trying to find the central angle because we actually know the measure of RS is right here. So what we're going to do is we're going to take our central angle, which we're not sure what it is. That's going to be over the whole thing of 360, which equals 44, because that's my arc length, over 2 times 15.28 times pi. So let's do a little simplifying. 2 times 15.28, 30.56. So When we cross multiply, we get 44 times 360 is 15,840 equal to 30.56 pi. And let's call our central angle, let's call it X. I like keeping it in terms of pi as long as I can. Again, if you want to multiply it out here, do 30.56 times. Now again, you have to remember, if you use 3.14 or if you use the pi button on your calculator, you may get slightly different numbers because pi never ends. So if you always use 3.14, it's going to round. So 30.56 pi divided out, we're going to get a central angle. So this angle right here is about 164, let's call it 0.988 degrees. And that looks right. About 164, about 165 if you round it. So this was a mistake. We were looking for the angle here. But that's, again, another example of I actually switched the left and the right side here. Usually we've been putting the central angle on the right side. I moved it over because that's what we were looking for. So really it's determining, of these four things, what do you have and what do you need to find? Find the perimeter of the shaded region. Okay, so find the blue part. So basically, I'm going to take, here's what I'm thinking. I'm going to take perimeter is the outside. So I need to find this stuff right here. So really, I know that, hey, this is 13 and this is 13. All I need to figure out is what is the arc length of this semicircle per se. Well, I know that the diameter is 6. So I'm going to use my proportion. Again, I'm trying to find the arc length over the circumference is 6 pi times my diameter equals a straight line is 180 over 360. 360x equals, let's see here, 180 times 6 is 1080 pi. Then I'm going to divide by 360, divide by 360. So 1080 pi divided by 360 gives us x is equal to, so our arc length is 9.42, let's call that 5. Now that's not my answer though. The answer is the perimeter. So the perimeter is going to be 13 plus 13 plus 9.425 plus 9.425. So 13 times 2 plus 9.425 times 2 is 44.85. This last example, let's see here, okay? So to find the perimeter, I'm going to find this section, which looks like is 6. This section is also 6. And then I need to find the arc length here and the arc length here. So if I'm looking for arc length over, this time I have the radius. So I'm going to do 2 times the radius times pi equals, I know that the central angle is 90 over 360. So when I cross multiply, I get 360x equals 90 times 6 is 540 pi. So if I divide this by 360, we get an arc length in x of 4.712 approximately. And then That's one of the arc lengths, and we have two of them. So again, our perimeter is 6 plus 6 plus 4.712 plus 4.712. And that gives us 21.424 units.